we're going to decode the invisible web that wraps around our entire planet. It's this absolute mathematical marvel that literally allows us to navigate our modern world. And in this session, we're going to break down exactly how the whole shebang works. Think about this for a second. You snap a selfie, you tag your location, and bam! How does your phone's GPS instantly pinpoint your exact spot on this massive spinning globe? Or, how does a delivery driver find your specific front door out of millions of other doors? It feels like magic, right? But it's actually pure, brilliant geometry. It all relies on what geographers call the geographic grid. Think of it as an imaginary framework of intersecting lines. It's essentially like giant graph paper wrapped tightly around the Earth. By using these crisscrossing lines, we can give every single place on the planet a completely unique, pinpointed address. Without this grid, our maps, our flights, and yep, our smartphones would be completely lost. Okay, let's dive into section 1, latitudes, the horizontal web. So let's break this grid down, starting with those horizontal lines. A great little trick to remember this is latitudes are lying down. These are the lines running horizontally from east to west across the globe. But okay, here's the tricky part that kind of catches a lot of people off guard. Even though they run east to west, they're actually used to measure how far north or south you are from the center. And crucially, they are perfectly parallel to one another. They literally never touch. So how many of these lines are we talking about? There are exactly 181 lines of latitude in total. You've got 90 lines stretching up above the 0-degree mark, which we all know is the equator, up into the northern hemisphere. Then you have another 90 lines stretching down below it into the southern hemisphere. And then of course you add the one equator itself. 90 plus 90 plus 1 gives us our 181 horizontal markers. And honestly, this next fact beautifully illustrates the mathematical perfection of this whole system. Because these lines are perfectly parallel, the distance between any two lines of latitude is always exactly 111 kilometers, every single time. Whether you're stepping off the equator or walking freezing cold near the poles, if you cross 1 degree of latitude, you've walked exactly 111 kilometers. Moving right along to section 2, Earth's 3 heat zones. Now, latitudes do way more than just measure physical distance on a map. Because of how our spherical Earth tilts toward the sun, these horizontal lines actually dictate our climate. By mapping where the sun's rays hit directly versus where they hit on a slant, geographers divide the Earth into 3 main areas. First step, the torrid zone. This is sandwiched right between the Tropic of Cancer and the Tropic of Capricorn. It's the hottest part of the Earth because it gets direct overhead sunlight. Next, you have the temperate zone, stretching from the tropics to the Arctic and Antarctic circles. Here, the sun's rays come in on a slant, creating a nice, moderate climate without crazy extreme temperature shifts. Finally, there's the frigid zone, extending from the circles to the extreme poles. Up there, the sun's rays barely even glance the surface, keeping it absolutely freezing year-round. So let's see how this builds into a complete grid by comparing those horizontal latitudes to the vertical web, the longitudes. If latitudes are lying down, longitudes are the long, standing lines. They run vertically from north to south, but we use them to measure how far east or west you are. And unlike latitudes, longitudes are not parallel. They're spaced out at the equator, but they perfectly intersect and converge right at the top and bottom, at the north and south poles. Now, just like the equator is a starting line for latitudes, the longitudes need a starting point too, right? This is the prime meridian, sitting exactly at 0 degrees. It's an imaginary line, sure, but it's pinned to a very real place. It passes directly through the Royal Observatory in Greenwich, London. The word meridian actually means midday, and this specific line is the anchor point for setting the entire world's standard time. Unlike the 181 latitudes, there are 360 lines of longitude wrapping around the Earth. Why 360? Well, because they form a complete circle, 180 degrees moving east and 180 degrees moving west, meeting right at the back of the globe. And we use this 360-degree circle to track something pretty incredible, time itself. Which brings us to section 3. Mastering time and dates. This is honestly one of the most fascinating features of the geographic grid. These invisible vertical lines aren't just for location. They literally control the clocks on our walls and the calendars on our desks. Time calculation follows a really specific mathematical logic. Think about it. The Earth is a sphere, so it completes a full 360-degree rotation every 24 hours. If you just divide 360 by 24, you get 15. That means the Earth rotates exactly 15 degrees of longitude every single hour. And since the Earth rotates from west to east, the eastern parts of the world see the sun first. So your golden rule here is, as you travel east across these longitudes, you add time. As you travel west, you subtract time. Let's look at a real-world example of how this calculation actually works. To avoid having 100 different local times, countries pick a standard meridian. India, for instance, uses a standard meridian of 82.5 degrees east. That line physically passes near the city of Mirzapur. Because it's to the east of Greenwich, we know it's ahead in time. When you do the math on those 82.5 degrees, it means the entire country of India is uniformly 5.5 hours ahead of Greenwich Mean Time. Now, if Greenwich is 0 degrees on the front of the globe, what's happening exactly on the opposite side? Well, on the back of the globe at 180 degrees is the international date line. This is literally where one day officially ends and the next begins. But if you look closely at a map, this line isn't perfectly straight. It's purposely drawn in a zigzag pattern. Why? Well, so it doesn't accidentally slice right through an island nation, splitting a single country into 2 completely different days. Imagine the absolute calendar chaos that would cause. All right, final section, section 4, the power of great circles. Let's zoom out for a second. When this grid of latitudes and longitudes works together on a massive planetary scale, it forms what geographers call great circles. To visualize a great circle, imagine cutting a lemon perfectly down the middle. If your knife goes straight through the absolute center, you divide that lemon into 2 absolutely equal halves. A great circle is any circular line drawn on the Earth's surface that shares the exact center of the Earth, slicing our planet into 2 perfect equal hemispheres. So, which lines on our grid actually make the cut? Well, because the Earth tapers off at the poles, the equator is the only horizontal latitude line that forms a great circle. The other latitudes are just too small. However, every single vertical longitude line, when paired with its exact opposite line on the back of the globe, naturally cuts straight through the Earth's center. This means they form an infinite number of great circles. Now, the crucial question. Why does any of this matter outside of a high school geography classroom? Because it's a massive, real-world tool. Since the Earth is curved, a straight line drawn on a flat paper map is actually a complete illusion. The true, absolute shortest, fastest route between any 2 points on a globe is along a great circle. Ship captains crossing vast oceans rely on these great circle routes to save time and fuel. Meteorologists use them to track massive global weather systems. It's the literal geometry that keeps global trade and travel moving efficiently. So the next time you pull out your phone, open up your map app and watch that little blue dot lock onto your location, take a second to appreciate the math making it all happen. Remember the invisible mathematical web of 181 latitudes and 360 longitudes wrapping all around you. And ask yourself, which exact degree of this incredible invisible grid are you standing on right now? Thanks for joining me on this explainer, and I'll catch you in the next one. Keep exploring.